All right. Welcome back to another stimulating Excel tutorial video. What we're going to be doing here is looking at the two kinds of graphs along with the statistical analysis that I would like you to do for the LEAP lab and all of the class data we have been collecting. First and foremost, what I would like to stress is please do not work with any of this data in the Google Sheet that you uploaded to the entire class. Grab that data and put it into your Excel program. Work with it there. If I go into our class Google Sheet and I find any graphs being made there or data being pulled and moved, I'm just going to delete it. So please grab the data, move it to your own computers, and begin to work with that data there. That's what I've done here. I've grabbed old data from a previous physiology class and I have put it here into my own Excel sheet. In this Excel sheet, we see that I have created many sub-sheets. These are going to be where I begin to take that data and distribute it and manipulate it and create graphs from. But here is the raw data. So this raw data came from a previous physiology class. That class took all the same data, the reporting of the biological sex, the are you an athlete, which means you exercise 3 or more times a week, the average size of their calf in centimeters, and the average vertical leap, also in centimeters. Now, our data online, as you input it, is going to have male and female participants all kind of mixed up. But after the last day of submission on the 12th of October, I will go into our Google Sheet and I will arrange it like this, where all of the male data is together and all of the female data is together. So you can use this tutorial video as you see me using it here. The first thing that we're going to be making is a scatter plot, and that scatter plot is going to be of all participants and their vertical leap. And we're going to be asking ourselves with the scatter plot, is the size of your calf going to correlate to how high you can jump? So we're going to plot the size of a person's calf in the x-axis, and in the y-axis we're going to be plotting how high they can jump. At this point, we do not care if that person is an athlete, if that person is a male or a female. All we care about is the size of their calf and how high they then can jump. So we're just going to grab this data here, pull it all the way down, press Control C, come over here, press Control V. Now we've got the data of the average calf size in centimeters and the average vertical leap in centimeters. We want to create a scatter plot where the x-axis is this and the y-axis is this. To do that in Excel, we go up to Insert. We go on over to our graph selections. Here's the scatter plot options. We'd like to choose this first one, please. And we see that we have a blank slate ready to input some data. So let's go up to Select Data right there. Here what we're going to be doing is adding a series. So I'm going to click this guy, Add Series. We don't really care too much about the series name at this point, but we do want to add in our X values. So clicking that guy will allow us to select all of these X's. And clicking this button here will allow us to select all of the corresponding Y's for those X's. We'll say OK, and we have created ourselves a scatter plot. Now hopefully what you see initially looking at this scatter plot is it looks a little nasty, right? It's kind of all clumped over here on this side. There's a lot of wasted space here. And when Excel just creates a chart for you, it assumes that each axis should start at 0, but nobody is measuring a calf size of 0. Everyone is measuring a calf size that looks like it's starting at least above 25. So the first thing that we would like to do is double click our x-axis here, and we would like to make our minimum 25. and that's going to center our data very nicely there. As always, we can put in a chart title that's going to make sense for this data. I'm going to leave that up to you and your imagination. We also want axis titles that also are informative and tell us the units used that we see here. Is this miles? Is this meters? Is this centimeters? Is this elephants? Who knows? Let's make sure the units are in there. Now what we have here is some nice data, but it's kind of hard to say what's going on. As your calf size increases, does your leap also increase? As your calf size increases, does your leap decrease? Or is there no real connection at all between the size of your calf and how high you can jump? In order to give us a better understanding of the trend of this data, is it going up, is it going down, is it going nowhere, we can add a trend line. To do that, we click this little guy and we come down to trend line. We'd say we'd like to add a trend line, and we're also going to want to add some equations and how well our data fits this trend line. So we're also going to click this arrow, and we're going to go to more options, which are going to give us more options. Now there's lots of different trend lines you can add. Excel has guessed that this is a linear trend, and we're also going to say that it's probably a linear trend between the X and the Y. Coming down, we see that we can add in a few things. We can display the equation of this trend line, which will give us a slope. That slope is going to tell us, is the data rising from left to right? Is it falling from left to right? Is it not going anywhere? So that's some important information. We also want to ask our software here, how well does this trend line really represent all of the data that we have? So we also want to display the R-squared value, which will tell us. Now usually it displays it here. That's kind of nasty, so I like to pull it up here so that we can actually see those numbers. The first thing that we have here, y equals 0.9x plus 0.0101. This is our y equals mx plus b, and this 0.9 in particular is our slope. So that tells us, because it's positive, this data is rising from left to right. As x gets bigger, y also gets bigger. And the number there can also tell you how much y gets bigger as x gets bigger. So in this case, y is going to get bigger by 0.9 for every increase in x. So you get 0.9 centimeters better jump as your calf gets larger. Now what we would also like to do, we've drawn this trend line. We see that it is positive. It's getting larger as this gets larger. But how well does it really fit our data, which are all these dots here? This is a made-up trend line. This kind of is showing us the trend of our data, but how well does it accurately portray our data? For that, we would look at our R-squared value, which tells you the percent of your data that kind of fits on this line. Our R-squared value is 0.08. It is a percent, so we would multiply that by 100 to find that about 8% of our data can be explained by this. That's not super impressive, right? So perhaps there doesn't seem to be much of a correlation between the size of your calf and how high you subsequently can leap. Now we are going to be taking our data and looking at some different stuff. Well, at least that was true for this semester. Let's see what happens in our new semester. This is a sample. This is some data, but let's get some more data and see what it says. Now we're also going to be making some comparisons. We're going to see if there's a difference based on sex. We're going to see if there's a difference based on training. And to do that, we're going to need to pull out specific information. So for this, we're no longer going to be making scatter plots. We're going to be making column charts. Column charts are going to be made with averages and standard deviations as error bars, and then going to have a t-test in order to see their actual differences if there's a statistical difference. So for the first column chart we're going to be creating, we are going to be comparing males and females and their average vertical leap. So that's the information we need to pull from our raw data. Over here, we have the reported biological sex in this column, so we take all of that. Holding down Control, we would also take all of the vertical leaps that correspond to that reported sex. Control C to copy. Control V to paste. So now what we have is our male leaps and our female leaps. We don't want to plot all of these points. We would rather plot an average and a standard deviation for both the males and for the females. That's the information we'd like to plot. So equals, you start typing AV, you're going to see the average. You can select all the information for the males, press enter, you get 45.38. Standard deviation, press enter, type ST, you're going to see the standard deviation, select all of the male data, close the parenthesis, press enter, you see a standard deviation of 7. So on average, males jumped about 45.4 centimeters high, and a range around that average of around 7. So 7 less and 7 more than 45. You can do the same thing for the females. So let's go ahead and quickly do that. The average for the female data and the standard deviation for the female data. So with these numbers, we now want to create a column chart that also has the standard deviations as error bars to kind of look at this data and be able to visualize it a little bit better. So in order to visualize this data a little bit better, I click on a cell out here and say I'd like to make a chart out here, please. And then I go to Insert. And then I go to the first one, which is Columns, and we'll choose that first column chart there. You have created the chart. Now you need to add the data. So we'll go up to Select Data. We're going to add a series. This series name, we'll say, is males. And the value is going to be this number right here. We'll say OK. Oops. Alright. Let's go ahead and click that little arrow, then say that. And say OK. And we need to add a new series. This one, series name would be females. And then we would add that average there. We would say OK. So saying OK then would give us our 2 columns here. So we have now created our 2 columns for the male and for the female. We now need to add some information to this graph so somebody reading it can actually know what is going on. So by clicking in here, we see that we could add axis titles, and we should always put units on those axis titles or name them appropriately. We see that we could put a chart title if we want, something that describes what is going on here. And we do need to add some error bars. So for that, I'm going to select our male column here. And I'm going to say I would like to add an error bar. And in particular, I'd like a little bit more options. For this, I want to go to Custom, and I'd like to specify exactly what that error bar should be. So in both the positive and negative deflections of that error bar, I would like it to be our standard deviation. So click for the positive there, click the little arrow next to the negative, click the exact same cell, and we say OK, and there we've got ourselves an error bar for our male. We also can do that for the female. So we've selected the female column here. We want to add an error bar. We would like more options on that error bar. We would like to specify the value by clicking Custom. Click that arrow for 6.42 and click that there, and we say OK. Now we got ourselves two columns, the male and the female, with their respective error bars here. Probably also want to put in a legend so that we know blue is males and orange here is females. Now, looking at this data, you would say to yourself, all right, it looks like males can jump higher. They've got a little bit more of an inconsistency than females, but that column is higher. Being a sound scientist, though, you want a little stats on your side. You want some statistical power to say, yes, this column is higher, and even if you account for all the variation, these numbers are different from these numbers. So what do you want? You want a t-test. So here we're going to run a t-test equals t will give you a t-test. You can select that. For a t-test, you need to input all the data of one series, all the data of the other series, select how many tails and what type of t-test you'd like to run. So this t-test is going to be comparing all of the male data, comma, then all the female data. You see different colors there that tells you you've put it in correctly, comma. Tails, is this a one or two tail distribution? The fact that it could go up or down means that it's 2, so we'll add a 2 in there. And usually we add a 1 at the very end to say paired. And with a 1 paired, that means that there is equal amounts of subjects in each series, but in this case there is actually different amounts of subjects in each series. I've never had a class that was equal in males and females, and so instead of a 1 here, we're going to put a 3 to say that there is unequal variance, unequal amount of subjects in each of our particular groupings. So pressing enter, we get ourselves a number, and remember we want to ask, is the p-value, is it less than 0.05? Our p-value is 3.8 times 10, that's the e to the -9. So that is basically, if you wanted to write that as a decimal, 0.0000000038. Is that less than 0.05? Yes. So not only can we say that it appears with this data, males jump higher than females, there is statistical accuracy to say so. Now, very important, the t-test doesn't tell you why, doesn't tell you how, doesn't give you any mechanisms, just tells you there's a difference. Those mechanisms are what you then begin to ponder and look into with other scientific experiments. So you would do the exact same thing, only for the male athletes versus non-athletes. So in this case, what you would want to be grabbing is just the male data, and then just the vertical leap of males, as well as if they reported being an athlete or not. So here, just in the males, we would want the athlete information and the vertical leap information. Control C and Control V. We might want to say athlete and then vertical leap. Now what we have here is a bit of an issue because we don't have our athletes grouped together and our non-athletes grouped together. We see yes, no, some mixes of yeses and nos. So we want to arrange this so that all of the yeses are together with their corresponding vertical leaps, and all of the nos are together with their corresponding vertical leaps. So we would capture all of this data like this. We would go up to Data. We would say Sort. We would like to sort by the athlete column, please. And if we say OK, we see that it sorts it into the non-athletes, and into the athletes. And all of the corresponding vertical leap came with each of these particular groupings. Here we would again create a column chart that's going to have non-athletes as one column and athletes as the other. There will be different statistical standard deviations, so make sure you figure those out. And then you'll run another t-test, again selecting the type 2 and type 3. So a two-tailed type 3 t-test, because there is a difference in the amount of athletes versus non-athletes of the males for this particular semester. All right, hope that helped. You do the same thing for the females, only of course with the female data. You collect all of this and turn it in together as a group project. We'll further be exploring this data and trying to figure out maybe what it means in the future. See you then.